Today we're talking about kitchen chemistry. You got a kitchen, Adam?
We're actually in my kitchen right now.
Wow.
Awesome.
Adam, what is chemistry?
Taking solids, liquids, and gases and changing.
Everything on planet Earth is made of either a solid, a liquid, or a gas.
Everything?
Everything. How do we take things that we know, mix them together, break them down, and how do they change? Whenever we see a change in chemistry, what do we call it?
Reaction.
A chemical reaction can be easily explained. It's when you take something, you do something to it, and in the end, it comes out completely different. Hey Adam,
Yeah.
what'd you have for lunch today?
Oh, I had a bagel.
Oh, I love bagels. Adam took something, a bagel. He did something to it. He ate it. His stomach digested it. And in the end, it comes out not quite a bagel anymore. What do we call that stuff, Adam?
Caca.
Chemistry. We call it chemistry.
Chemistry.
Yeah.
There we go.
That's it. Nailed it. Now that we know what a chemical reaction is, let's see if we can have an experiment that you can try at home. You're gonna need a blender. Doesn't matter if it's a big blender or a single serving blender. A red cabbage. Now, they call it a red cabbage, but it looks purple to me. You're gonna need some sort of strainer. A variety of see-through liquids. Now, a lot of young scientists think that this is water. You can't just assume because a liquid is clear that it's water. A little bit of water. Now let's see our first experiment. So our first step is to take our red cabbage. You're going to take off these big leaves and you're going to separate it into smaller parts. Adam, show them how it's done. Oh gosh, he's strong. Bone. Are you seeing this? Shredded purple cabbage. And we're going to want to put it in our blender as much as you can fit. Let's fill her up. Whoa, just right. Now let's blend it up. Cabbage juice, here we come. Whoa.
What do you think?
I think it's lunchtime. We're going to take this cabbage juice and we're going to strain it. So let's take our cup. Pour your cabbage juice right into it. It smells a little funny. We are going to pour this cabbage juice inside of our see-through liquids. Now you don't know what's inside of these cups, but we do. But we'll let you know so that you can try this at home for yourself. The pH scale shows us if a liquid is an acid or a base. If we see pink, acid. If we see like a bluish green, base. Adam, go ahead and pour just a little bit inside. Whoa. What do you think it is?
I would have to say it's an acid.
It's an acid. Let's try our next one. Whoa. Now we're blue and green. What's that? Base. That's right. Let's try another one. Oh, what color do we have now?
We got purple.
Let's try this one. Ooh, what is it?
It's an acid.
It's an acid. You know, because look how bright the pink is. Now this see-through liquid, wow, it's not so clear. There's a little bit of a yellowish tint. But let's see if we can tell if it's an acid or a base based on our cabbage juice. Whoa, I'm all about that base. That's right. Wow, I have a question for you, Adam. If you could put these base on this side, acids on this side, and neutral right in the middle, how would you arrange these cups? 10, 9, whoa! Based on the colors, we can learn all about the pH scale. For our acids, we used vinegar. Then we used Sprite. That's right. Now neutral, just as you can probably guess, it's right in the middle. Just right. We have water. And then once we start getting into our base, first of all, we have a weak base. I just put some water with some baking soda. And finally, for our strongest base, this is ammonia. All right, Adam. Now that we've learned all about the pH scale, let's move on to our next experiment. But before we can do our next experiment, We don't really have the lab space, do we?
No.
Clean as you go, sign of the pro. Let's move some of these bottles. Our next experiment, we're talking about physical and chemical changes. A physical change. Not that big a deal.
Yeah.
Could I still tape this back together?
You can tape it, you can glue it.
A chemical change would be if I changed the entire thing entirely. It would be like taking this piece of paper, crumbling it up.
It's still paper.
Not if I light it on fire.
What do you mean?
Like this.
I-
I'm scared! Adam,
Yeah.
can you still tape this paper together?
I don't think so.
Could you glue it together?
I don't think. No, see, it's falling apart everywhere.
Let's see if we can have an example of a physical change. What we're gonna do is called chromatography. We're gonna take coffee filters, Skittles, spray water bottle. Ah! Ah! We're gonna use one coffee filter apiece. We're gonna put a few Skittles, 4 to 6, on each of our coffee filters. We're gonna take those Skittles and we're gonna spray them. On top of them, we have what's called a pigment. By spraying water on them, we can actually strip off that pigment and make it go onto our coffee filter. We want to take it up, we want to give it a shake. We want to make sure that color gets all over, spread it around. And by doing that, you can create some really cool tie-dye colors. Hey Adam,
Yeah.
should we show them our cool design that we made today?
Pretty awesome.
Let's check it out. Well, I guess that's our last experiment of the day. We'll see you next time. This has been a Super Science Short. I'm Jacob. This is
Adam.
signing off. It's like
Yeah, but I
signing.
got it off on the side, so.
It's like off it.
Oh, play on
I'm
words.
signing.
Oh no, I get it. It's punny.